Okay, let's go. Are we live? We're live, I guess. Yeah, nice. Okay, let's go. So today I'm trying to learn to code in just a day. So let's see how far we've come. And my goal is to be able to program a video game after today or today.
Hello guys and welcome to my channel. My name
And let's just start right in. You see in the top and in the bottom right corner the tutorial I'm currently watching. In the background you just see Unity, the, I guess, basic program for video games. And in the bottom left corner you see me.
My name is Stefan Persson, also known as Invencia, and this time around I'm going to be making the most basic Unity tutorial that I will ever make. If you're brand new to Unity, or even
Sounds
if you
good.
want to brush up on your basic skills,
Just quick, for the first 2 hours around, I'm trying to learn the basics of Unity and C#, I guess. I think it's C#, the programming language. And after that, I'm trying to code my first game. So let's see.
or if you want to write your first C# script, even though it's a very basic one, this is a video just for you. I've been using Unity for over 8 years now. I've created a lot of assets that I sell in the asset store, and I create a lot of small games, especially for Ludum Dare, for example. I've done 11 consecutive Ludum Dare games where you have to make a game from scratch in only 48 hours. And currently, I'm working on a multiplayer RTS game with a colleague of mine, and we're 1 year into development. I'll be announcing that later on during this year. So, again, sit back, have a cup of coffee, a can of Coke, even a cup of tea if that's what you want. And let's just get started with the most basic Unity tutorial ever. So I've downloaded the most recent version of Unity that's available at the moment, 2019.4. And when you start that one, you might get this Unity hub up. I've got a lot of Unity versions installed.
Okay, let's skip a bit ahead because I already downloaded Unity. Okay, well, never mind.
Since I work with a lot of assets, so you should hopefully not have this many. First, I'm going to use this little drop down here to ensure that it's the version of Unity that I want. And I want the most recent one that I've downloaded yesterday, 2019.4.4 F1. So it should look pretty much the same in any version of Unity that you've downloaded if it's fairly recent. And then I'm going to make a 3D project here, and we're going to just name it something like Unity Basics. And then I'll hit create. Okay, so I normally use the professional skin, but I've reverted back to the basic skin now, so it should hopefully look very similar to this with the color scheme and everything like that if you're not running the Plus or Pro version yourself. And I've also reset to make sure I've got the default view, so the layout of the screen should be pretty much identical if you've started a brand new copy of Unity. First, let's cover the user interface a little bit here in part 1. And in the center here, you have something called the scene view, and imagine yourself that you're a director of a film. So basically what the scene view is everything, including the stage, but you also have the cameras, the lights, maybe some actors off stage a little bit that are about to come in just a moment. So that's the scene view. Basically, you see everything that will make up your game. And this is actually where you're going to be designing your game as well. On this second tab here, you have the game window, and that's basically what the camera sees. So imagine that as if you were in a theater, for example, in a movie theater, and you were looking at the big screen. And whatever goes.
I like how he's showing us what it looks like if you have a game, or just to imagine how it looks like later. That's really good.
Goes on that screen, that's the game view, or for in our case, it's going to be the player that's playing the game. Whatever the camera sees or what the player should see is what's going to be visible in this game view. And you can see that by default here, it's got this skybox with a blue sky and a horizon. And if we look in the scene view, we can see that it's actually this little camera here that's looking at something. And as you can see here, the camera itself and the light is not visible. They're just showing the scene and lighting the scene. On the left here, you have something called a hierarchy, and that's basically like an inventory list. So of everything that's in your scene. So they're very linked together. The scene view has a lot of stuff with icons and items, and the hierarchy is a list of that view. And it's a collapsible list. You can
basically like the files, I would call it, I guess, with which you're working with. So if you have a programming background, it's basically, I guess, different files you use.
You can collapse and expand a few of these things here. As you can see, you've got the main camera, which is the same as here, and the directional light. If you click on something here, it'll also select it in the scene view. So if you click on it in the hierarchy, it will select it in the scene view as well. You can arrange things up and down here by selecting something and dragging it and dropping it above and below this list. And normally it doesn't really have that much of an impact for your game. But if you're making a user interface or if you're making a 2D game, the order will make a difference because it's rendering in the layer from top to bottom. But if you've got, for example, a UI, it will render from the top and down. So if you have a lot of boxes or windows that are on top of each other, it'll render them in that order. So it's going to be the one that's furthest down. That's going to be the one that's on top. But in a 3D viewport like this, like in our game, we're not going to be needing to sort any of this because the sorting is taking care of the camera and the distance that objects have from the camera. So in this hierarchy view, you will have a lot of stuff for your game. For example, you'll have...
Give me just a second.
If you're making a platformer, you'll have a...
Okay, just one moment. I'm just looking up something about the stream. Okay. Oh, looks good. Okay. We can continue.
A list of a bunch of tiles, and you'll have your player, the weapon that he's carrying, all the enemies that he can encounter, and they'll also be showing somewhere in the scene. You could also instantiate stuff during the runtime. We won't really be doing that this time, because when you make a very simple game, you can basically throw everything into the scene and have it active at all the time. But when you're making more and more complex games, you'll want to have stuff to be created and removed dynamically. But again, that's for a later video. Down at the bottom here, you have something called a project window, and by default, it's split into two parts. You've got the left sort of a folder view here, and on the right, you'll have a bunch of icons, and it's very.
Okay, I don't see this because my camera is in front of it, but
down to do a one-column layout sometimes. But the default view is 2 columns, and that's what I'll be using now. Think of the project folder as a warehouse.
But I guess it's not that important. I guess the camera is pretty fine where it is, and also the tutorial.
For example, again, if we're making a movie and you're the director and you want to make that film, the warehouse or the project window is where you'll have all the stuff that's stashed away for later use. Maybe it's stuff for your next scene or a future level. Maybe it's those tiles covered in snow or the next boss that you'll encounter a few levels down the line. And then finally in the UI here, we have on the right side something called the inspector. And when you have something selected in the scene or in the hierarchy here, whichever, then you'll have a bunch of stuff for that object that you've selected.
But it looks pretty much, I mean, okay, it's a bit different, but it looks somewhat like if you program an Android game, or Android's not really game, just an app. With Android Studio, you also have like this kind of inspector. Wait, no, I'm just mixing things up with Swift. In Swift you have the inspector, never mind. In Swift, but generally, like the layout looks somewhat like Android app development.
Selected in this inspector. Just think of it as a magnifying glass that zooms in on an object, and you can change some values here. For example, you can type in different values. You can drag some sliders, use the drop downs buttons, and you can add and remove things. We'll go through that in a lot more detail in just a moment. So that's the inspector, and you'll be using that one a lot. We're going to be talking about game objects, transforms, and components. And those terms are very common in Unity. Let's start by creating a game object. I'm going to right click now here in the hierarchy, and we're going to create something called, let's create a 3D object, and let's make it a cube. And this is one of the primitive that comes with Unity by default. And it's created a little cube. We can see it here in the hierarchy, but we can also see it here in the scene view. What we've just created now is called a game object, and everything in Unity is a game object. This camera is a game object, this light is a game object, and this cube that we've just created is also a game object.
Interesting.
And a game object is a collection of stuff like something called a transform and a lot of components that we can add to this game object. Not only did it appear here in the scene and in our little inventory hierarchy list here, but it also appeared in the game view because we happen to create it in the center of the scene and we've got a camera that's looking at that one. And the game view will automatically update as you make changes to your game. If we even select this camera here, you get a little preview down here in the lower right corner, and you can see that it's, even though it's a little bit faint, you can see that it's actually looking at this cube. And Unity's coordinate system is working on X, Y, Z, where Z is forward. And that's the blue arrow here. And the camera is always looking forward in the forward direction. And as you can see here, the camera is looking at this cube, and we see it in the preview, and we see it here in the game view itself. We can rotate the view here. If we hold the Alt key and then the left mouse button, we can rotate around in the scene view here as we edit. We'll need to be able to rotate and see stuff from different angles when we want to place things or modify things. And that has no impact on the game itself. As you can see, when I rotate here, the camera is still looking forward in its own direction, and it's looking at that cube. Also in the UI that I haven't covered yet is in the top left here, you have a little toolbar. And you've got stuff like a move tool.
Wait. I don't have those. Or is
for example,
okay, well, I guess
rotate tool and a scale tool. You can also toggle these with the keyboard. So W is this move tool, E is the rotation tool, and R is scaling tool. So if you're coming from out of Blender, where I do a lot of my work, then it's not the same keys. So it's just a brain melt, but you'll get used to it in the end. You just have to adjust a little bit and then rethink it. If we press W now, or we click this little move tool here, you can see that you get this arrow gizmo on the game object. And if I slide it here, you can see that the camera is moving forward, and we'll get closer to this cube here. And I can slide it back.
Oh yeah, you see it here in the main camera. Pretty good.
And also, if I press E or select this rotate tool, we can rotate it on an axis. So we rotate the camera in different angles. But let's move that one back to the default location. We can press Ctrl Z a few times, and the camera is back to its default location here. And then we can also select the cube instead, either by clicking it here, or we could have also clicked on the cube itself here in the scene view. And in the same way here, you can move it up and down, left and right, and position it where you want it in your game world. And remember that we talked about this inspector thing on the right here. And as you can see, when I drag this object here, it updates the position. So if I go up, it changes the Y coordinates. And if I go down, it changes it down. We can also just click here, press 0, click, press 0, press 0. So we can type in values there if we want an exact positioning there. So what is a transform anyway? A transform is the position, rotation, and scale of a game object. Every game object will have a transform in your game. And again, it's the position, rotation, and scale of that game object. And by default, the scale is always 1, and that's what you should try to operate at most times. You get better performance if stuff is scaled 1, and you also have less problems if you have a hierarchy of game objects. If they're scaled differently, it'll get a little bit confusing with the scales. And we can also see a few other things here in the inspector. And when you create this default game object, or the cube, not only did it add this transform automatically, it also has a bunch of components here. It's got something called a mesh filter, and this is telling the graphics card what type of a mesh it should be rendering. And in this case, it's a cube. If I click on this little button here, you can see that I can select a few different meshes here. And these are the default primitives that come with Unity. And later on, when you make your game, you'll probably import 3D objects from Blender or something like that. And if you do that, then they will also show up here. So the mesh filter tells the graphics.
1 sec. Let me just turn off streamer mode. Okay. Probably somewhere here, yeah. Ooh. Oops. Does it work now? No, it doesn't. Nice. Okay. Oh, well, whatever.
Card, which mesh it should be rendering. Then we have something called the mesh render, and that's actually responsible to telling the graphics card how to render this mesh. It knows that it's a cube, but we can also assign it stuff like a material, and it's got a default material here by default. How we should be interacting with shadows. Should it be casting shadows? Should it be receiving shadows? We've got stuff like probes and stuff like that. We don't have to worry about that. That's a bit of a future thing. And we also have this thing called a box collider, and a collider is telling the physics engine how it should be interacting or how it should be colliding with other objects in your scene. And by default, it also gets this box collider automatically. So in this inspector here, What we just covered now are different components that are attached to this game object. If it looks a bit confusing, don't worry too much about it now, because as you start making your own games and prototypes with Unity, this sort of stuff will come to you through the process. You'll repeat it over and over again, and it'll start making its way into your brain. So again, don't worry about it too much. Come back to this video if you need it in the future as well. And you can go through this back and forth, but you'll learn this as you make your own games. Don't worry about it. Now let's rename this cube. We should make something that resembles a little bit of a game. So I can click on it here. You can either rename it up here by typing it in here. Hello. And that changed it here in the hierarchy as well. And you can also click on it here and press F2 to rename it. And we're going to make something that could be the start of a platforming game. So let's call this one Floor Tile. So that's the start of our platforming game. Let's press play and see if it's a fun game. It automatically switches us to the game view. That's what happens when you press play. But it's not much of a fun game yet. And technically, it's not even a game, because a game requires some form of user input, and it should also be some challenges that you need to overcome, and you should be rewarded for overcoming those challenges, and we haven't done any of those. So let's press the play button again to stop this. Okay, since we call this cube a floor tile, we should make it look a little bit more like a floor tile from a platforming game. So we're going to create our first material now to change the color. And down here in the project, let's make sure we have the assets folder selected here. And in the empty space here, let's right click and create a new folder. We want to keep things tidy. So let's name this one materials. I usually create folders like this, and I put materials in one folder so I know where to find them. And we can double click on this folder now, and let's right click again now and create something else. Let's make it a material this time. So we're going to name this one floor dirt, because this is going to be the brown part of our tile. We want to change the color of this. We don't want gray dirt. So on the right here, when I've got this floor dirt material selected, on the right here, we still have the inspector. And as you can see, that can work here as well. Not only when you select stuff in your scene, but also when you select stuff in your warehouse or in your project folder, you can modify those. So let's change the color here from white of this material. So let's change it to a brown dirt color. We can see a little preview down here at the bottom, and dirt rarely shines unless you've polished it. So let's let's bring this smoothness slider down, and you can see that the shininess disappeared. It's still getting lit and it has some shadow, but it's not shiny. Pretty dark now. Don't polish it, turd. Okay, so now we need to move this floor dirt material. We'll click on it and drag it onto the cube here. You can either do it onto the one up here or straight into the scene. Let's drop it on the cube here in the scene since we can see it. And if I select the floor tile now, you can actually see that it replaced this material here, the first.
Give me a sec. Somewhat like this, okay. Wait, how did he drag it?
Element to. We'll click on it
from there.
Onto the cube here. You can either do it onto the one up here or straight into the scene. Let's drop.
Okay, now it's a bit too light, I guess. Yeah, it looks good.
But on the cube here in the scene, since we can see it. And if I select the floor tile now, you can actually see that it replaced this material here, the first element, to floor dirt. We dragged it onto there, but you could technically drag it onto there, or you could have dragged it onto there. There's many ways to do it. So pick your...
materials just collapsed. Okay, yeah, I see.
Weapon of choice. Okay, so a little bit more about the navigation. So I mentioned before that in this scene view, we can hold Alt and then click the left mouse button to rotate around the view. You can also hold the Shift key down and press your middle mouse button to pan around in your scene. And you can use the scroll wheel to zoom in and out. And sometimes you get a little bit off-centered like this, and when you start rotating, it's rotating way out of what you want to be watching. And if you select the floor tile here and then press F, it will frame it into view. That's very useful as well. And now we can, when we rotate around it, it nicely orbits around our object. So remember, the F key will focus onto a game object. Same thing, if I select the camera, press F, then it centers on that one. So let's go back to our floor tile now. Zoom out a little bit, and here we go. All right, now we're gonna make it look a little bit more, again, like a floor tile in a platforming game. So we can actually select this game object that we already have selected. And then I press Control D, and that created a copy of it here. And we can't really see anything different here in the scene view because it created a copy in the exact same location. But let's rename this first of all. We'll click on it here in the hierarchy, press F2, and let's just name it grass. And then we also need to make a grass material. So let's click.
You don't actually have to F2 on this. You can just Wait, how did it work? Okay, double click. But not like, probably not like this double click, yeah, not like that. Just if you're on it, just left click one more and you can change the name also. Okay. Anyway, where are we?
Down here in the project view, we click our floor dirt material, press Ctrl D, and it's created a copy here. So let's press F2 and name it grass. And then we should change this as well. Make sure that it's selected, and then we click on the albedo color up here and make it green. Green like grass. Okay, there we go. And now it'll be tricky to move it onto here because we don't know. We've got two game objects now with the same type of the cube and in the same location. So we don't necessarily know which object we're dragging it onto here. So here's a good example where you want to drag it onto your grass here instead.
Yeah, or we just...
And again, it showed it.
Make the floor tile invisible and drag it onto here. Now it should be... Yeah, now it's just grass.
It probably would have hit the right object, but we don't know that for sure. But now we know that it was the grass tile. So if I select the grass here, we can see that it's got the grass material, and here the floor tile is got the floor dirt. But they're in the exact same location. So let's make sure we've got the grass selected here and then slide it up a little bit on this axis. And now you can see something called Z fighting. Z fighting is when the graphics card is trying to render surfaces that are exactly in the same location on the one plane. Then it doesn't really know which one to pick, so it just does its best job. And here we can see that sometimes it's picking the dirt and sometimes it's picking the grass to render. And this is a bit of a problem, but we can work around that for now. Let's start by sending it up to make sure we've got it. We can type here in the inspector 0.5, and now we know that we raise the grass up to half the distance here. The cubes in Unity by default are 1 by 1 by 1 units, and we've raised it now on the y-axis, which is up.
No, looks good.
And now we can also change the scale here. Let's make the X scale 1.01, and you can see that the Z fighting just disappeared here. And we'll do the same on the Z axis here, 1.01. And now since that cube, the grass cube, is slightly bigger, it only has to be a little bit bigger, then the graphics card has enough precision now to not have to let them fight. But it's a bit thick, the grass, so we have to mow this a little bit. Let's change the Y scale here to 0.1, and that compresses this cube down into a flat.
0.1 also works.
To look a little bit like
that's pretty good.
Like a floor.
It makes things just a bit easier if you can press 0.1 instead of 0.1. I mean, it's not that big of a deal, but still.
Tile in a platforming game. I mentioned before that you should try to avoid
like a Minecraft block in like version 1.0 or something.
But for this purpose, if you're going to create primitive game objects like this using the primitive cubes, you don't really have any options. You have to change the scale. But you want to avoid changing the scale if you're designing your game objects or your meshes in Blender, for example. Try to model them in the scale that they will be using in the game engine, because it will save you a lot of time and hassle later on. So the floor tile and the grass, they're two different game objects. So if I move this floor tile here, you can see that the grass stays there. And we don't really want that to happen.
Component,
the same way if we move the grass here, just the grass moves. So we can actually change the hierarchy. That's why, again, why it's called a hierarchy window here, because I can pick this grass now, click on it, hold it, and I drag it onto the floor tile.
Ooh.
And that made the grass game object a child of the floor tile
object.
Okay. I can still move the grass independently, like this. Control Z, let's move it back. But if I click on the floor tile and move it, then this grass is a child, and then it will follow its parent around. So that's very useful. You'll often have hierarchies in game objects. Useful. For example, if you've got a spaceship, you'll have maybe wings, you'll have weapons as children, you'll have turrets, flames, thrusters, you name it. But again, still both are game objects with its own set of components. So keep that in mind. Also, in the inspector here now, that we can see that to transform, if we select this floor tile, it's showing the position, and this happens to be the position in the world because this is the root object. It's placed at the very top of our hierarchy here. So whatever value it says here in the position for this transform is the world position. So when we centered it to 0, 0, 0.
Let me just... fix the cam a bit. Okay, should be better now.
Here, it's in the center of our world. This is in relation to its parent. So if I move this floor tile to the side here, let's change the position here on the x-axis. When I click the grass now,
is the same.
What? it'll still say 0.
Oh, wait, what?
And we've shifted it up on the Y position, but X that we changed for the parent is still 0. And that's because the child is showing here in the inspector its relative position to the parent. All right, think of it like this. I'm a parent. I've got a bunch of kids. And for example, when they were younger, I used to carry them in my arms. So they were in a relative position to me. They were 0, 0, 0 centimeters from me in an XYZ coordinate system. But I could walk around in the house. I could go up the stairs, down. I could change my position, but my child's position relative to me was in the same location. If I held my child out like this, maybe 1 meter, if I've got long enough arms from myself, then the relative position from me is 1 meter in my Z direction, in my forward direction. And then, for example, let's say there was a strange sound coming from this baby, something really strange, and then it started to stink. Then I can reparent this child object to another parent, and then the problem pretty much goes away. It takes care of itself that way. So think of it like that if you're having struggles now with the local coordinate system. Maybe that'll help. Okay, now we're going to talk about...
It was kind of a weird explanation, but it worked.
Prefabs, and prefabs are prefabricated game objects, and that's something you should really consider using. Pretty much every game will be using prefabs that you make, and it'll save you a lot of time and hassle, so try to make sure that you grasp the concept of this. Let's go back to the project folder here, and let's make sure we go to the root here in the assets, and let's right-click here and create a new folder again, and let's call this one prefabs. Remember, let's keep it tidy now. We can double-click to get into this folder. And if I drag this floor tile now, I just click on it in the hierarchy and then drag it into this folder. We've created our first prefab. That's how simple it is. And you can see up here... Remember, let's keep it tidy now. We can double-click to get into this folder. And if I drag this floor tile now, I just click on it in the hierarchy and then drag it into this folder. We've created our first prefab. That's how simple it is. And you can see up here, it turned blue now, the floor tile and the child. And that's how Unity will tell you that this is actually a prefab that you've got. Let's drag this prefab now that we've created from the project folder, from our warehouse, into the scene. And we can instantiate or create this prefab or an instance of this prefab now in our scene. And since the game is working in a 3-dimensional space and our monitors only show 2 dimensions, it could be a little bit difficult to place this. It does help you a little bit, because if you hit a collider, it will actually try to align it to that collider, as you can see. So that can help you sometimes when you position it. But let's just drop it anywhere in the scene now, and it's automatically selected it for us. And let's just manually change this position. Maybe we'll put it to x equals 3, 0, 0, and rotate. Okay, let's make a smaller gap. Let's just put it at position 2 here. We've got 2 game objects now, but they're based on the same prefab here. You can actually duplicate the objects here straight in your scene as well. If I have this one selected now, I press Ctrl T.
Oh, wait. It's because, this one is not set 0. I was so confused why these two are not aligning.
The scene view.
That makes sense.
If I hold the Control key and slide it, it'll actually snap it nicely in the coordinate system here. And we could snap move it to X location 3 here. And now we've got 3 prefab instances here. And Unity will know that it was a prefab. We've got 2 game objects now, but they're based on the same prefab here. You can actually duplicate the objects here straight in your scene as well. If I have this one selected now, I press Ctrl D here in the scene view. If I hold the Control key and slide it, it'll actually snap it nicely in the coordinate system here. And we could snap move it to X location 3 here. And now we've got 3 prefab instances here. And Unity will know that it was a prefab that you copied when we pressed Ctrl D here. So it's still using. You can see that it's still blue here. And all of these 3...
Wait, it's not blue for me. Wait, what? Oh no, this one is not... Wait, why is this one not a prefab? Wait, what? Copied it from there, didn't I? Yeah, okay.
Game objects now and their children are using this prefab that we've created earlier. We want to keep things tidy, as I mentioned before, and we can see that in the hierarchy now we're starting to mess things up a little bit. It's starting to look a little bit messy, so we can fix that. Let's right-click here in the hierarchy and create a new empty game object. We'll press F2 and let's rename it to level. And we can also manually, I like to keep all my objects that are placeholders or folder objects to 000 in the scene, because then the children of that one will have the same coordinate that it will show in its transform will be the same as the world position. If your level object here is a little bit offset, it'll look a bit strange. So keep that in mind. Try to keep these folder objects to 0, 0, 0 in your scene. And then I can click on these, and then I can hold the control key and multi-select these objects here, and then we can drag them into the hierarchy of the level. And the beautiful thing now is that we can collapse this, so we can hide it. And out of sight, out of mind. Remember, you can also hold the Alt key when I expand on this little triangle. And as you can see, it automatically also expanded the children here as well. So if you want to expand the whole hierarchy, hold the Alt key when you press on these little triangles, and it'll collapse and decollapse them. So what is the deal now with prefabs, and why are they so useful? If I select this game object, we can see, let's expand this here as well. I've already messed it up again, but we can collapse this again later on. But if I select the floor tile, we can see that it has a box collider here. And if I look on the grass here, we can see that it also has a box collider. And when you're making a game, you want to try to reduce the number of colliders if you can, for two reasons, really. One of them is performance. The fewer colliders that you have, the better your game will perform, especially on mobile devices, for example. And also, it makes it a little bit less complex to work with fewer colliders. So you'll know a little bit better what the physics engine is up to and what could be colliding with what. So now we want to remove this grass collider, and we want to make sure that happens for all the game objects. So let's double click on this prefab now instead down here. And you can see that the background here turned blue. It looks a little bit different. And also here we've got in the hierarchy, we've got this title now saying floor tile, and we're actually in prefab editing mode now. And it'll only show you, it won't show you anything from the scene. It'll just show you stuff that's related to this prefab. So let's go to the grass object here and see this box collider. We can right click on it and remove component. And now we've taken away the collider from the grass part, but the floor tile itself still has this bigger collider on it. If we click this little left arrow or back arrow here, now when we select these objects, we can actually expand all of these and see that none of these have the box collider anymore for the grass. So that's why the prefabs are...
Wait, why is this one not a prefab? I don't understand. You just dragged it into here, and for me it's not a prefab. Can I drag it into here? That's still not a prefab. Wait, what? Anyway, I'm just copying this one and moving this onto here. Yeah, and then it's working. Yeah, okay. I don't know why, but... And these are not in level again.
So useful, and you can make one change. Imagine if you had 1,000 floor tiles in a level now and you didn't use prefabs. You'd have that pain to do all this work repetitive.
Sounds fun.
So keep that in mind. Use prefabs and make the modifications to the prefab. The beautiful thing is that you can also override stuff that prefabs are using. So let's say this floor tile, we wanted the grass to be a little bit taller on this one. So let's go into this grass object, and instead of going into the prefab now, we're actually in this instance of this prefab. So we've selected in this scene view here. And let's make the grass a little bit thicker here. So the Y scale for this grass component, let's change it to 0.4. And we can see that the grass got a lot thicker here, but it didn't affect the other tiles. And another thing that happened is that this text here turned bold, and it's got a little blue mark here. I think the blue mark is new in the new UI here, but it went bold. And we can also see that just the Y position or the Y component for the scale here turned bold. And this is how we can see that it's actually overriding a value. We can right click here now and do either revert if we want to go back to make sure that it was the same as all the other prefabs. It's quite often that you want to do that. You can also do right click and apply to prefab if you want to apply it to all the instances. But quite often, Control Z out of that one. Sometimes we just want to override a value of a prefab. And you can do this pretty much anywhere. You could change the material for this one. And you can see it turns bold and it's got this little blue thing here. So that's why when we know that we're overriding it. If we pick the parent root here of the prefab as well, we can see that there is something here in the inspector, and it's got overrides. And here is a list as well that could be useful, that you can see which overrides are currently in it.
I can't click override. Does he have something different?
And
anything selected that I haven't? Untagged? No, I just can't. access these prefab options? I don't know.
Here's a list as well that could be useful. That
won't
you can
be,
see which
won't be important, I guess.
in effect. You can revert them all,
at least for now.
them all, for example, or if you want to just check what you have changed or overridden, that's possible to do here. And here's a little shortcut as well to select the prefab, and it highlights it down here.
Can't use that as well.
If you want to go into there. So there are a few shortcuts for you. Okay, so let's go out of prefab editing mode, and let's also revert this one. We don't want the grass to be thicker there, or greener for that matter, on the other side. And let's press play again, see if it's a fun game. No, I'm pressing a lot of stuff here.
Pretty fun game, I guess.
Can't do anything. We just got a bunch of tiles. So, no fun game. Let's press stop again. So now we're going to add a player to see if we can make this game
now it's interesting.
First of all, remember, out of sight, out of mind. So let's collapse the level for now. And let's right-click in the hierarchy and create a 3D object. And this time, let's create a capsule. And when you create games, especially your first one, don't start modeling lots of complex stuff in Blender with walk animations and try to bring those in. Keep it simple like this, I'd suggest. So the tiles, they're just boxes. The player, it'll be a stupid capsule, but live with that for now. It's really good to keep it so simple, just so you get the basics down. And then you can gradually upgrade your game by replacing this capsule with an actual, maybe a sliding player, and then maybe a walking player in the end. But we're going to make a capsule for now, so that's what I recommend to start with. Let's manually type in the transform here to 0, 0, 0 to begin with, to have it center in the scene. And now it's in the same location as this tile, so we can move it up a little bit in the air, and that's okay. We can have it fall down. Gravity will bring him down to the ground in just a minute. But it's also a little bit big for being a player, maybe compared to the tile. So let's change the scale to 0.5, 0.5, 0.5. Maybe we'll keep the Y at an even 2 here as well. Also, this light doesn't have to be there to annoy you, because this is a directional light. It doesn't really matter where it's placed. You can send it in far away, far away, because it'll always just have the same angle of the light. So you can just move that one out of the sight. Let's go back to our player. Let's rename this one. It's not going to be called capsule. We're going to call it player. Let's do it one more time. Let's press play and see if this is a fun game. Nope, it still sucks. Okay, so what can we do to improve this? Well, we should be adding some physics now. Since it's a platformer, we want the player to be falling down and hitting the tile and fall off the world if he misses a tile. We're going to add a component now called a rigid body. And a rigid body is something I usually get if I do something complicated, like trying to pick up a sock from the floor. I'll pull my back and I get a really rigid body. But in this case, that's
old man.
So we can add a component here. So in the inspector with the capsule selected, we'll click add component. We can type in here rigid. And we don't want the 2D one because we're making a 3D game. So let's pick 3D, or the one just called rigid body here. By default, it gets a mass of 1 kilogram, but that's fine for now. We can just keep it like that. We also have a few other things like, should we apply gravity? And yes, we should. And should it have drag? No, it doesn't have to have drag at the moment. And so that's air resistance and things like that. Just keep everything default, and let's press play again. And we can see now that the player, or capsule, just fell down and hit the ground. So it's already, Unity's physics engine is already in the works right now. So
where did everything go? Bro, come on. Why is everything gone now? I shouldn't take that long to bring it back. This is not a prefab again, I don't understand. Why is this not a prefab? Okay, never mind, I'm just dragging it here, dragging it there, dragging it back Does it work? Okay. But I can just copy it. And bring it back like this. And then bring these to level and create a 3D object capsule. Did he name it? Yeah, player, okay. Scale was 0.5. Oops. And rigid body. Okay, I think just dragged up the light a bit, but that doesn't matter. Does it work now? Bro, what? What? It just keeps disappearing. Why does it? Let me just check this. No, they're just. I don't know what I should do, to be honest. Maybe resetting. Let's just copy the error code. The code is trying to work on an object as null value as its reference. Being initialized. Yeah, but which one? Do I see which one it is? Classic SCM editor project downloader. This is legit base. I created a new project and started it. Why is there an error, Unity? Come on. I haven't even done anything. Just have to guess now. Bro, can't be flare, I guess. I mean, that's set to none, but material. coding in a nutshell. Yeah, but what isn't set? What isn't initialized? Okay, can't be anything I created. Or it could be, but the problem was there before, so it has to do with something of the default things that were there. But what? Does he have anything different than I do? Maybe some setting? Can't really see anything. Oh, bro, come on. What is this, man? Maybe I could write Unity in front of it. How do I get there, by the way? Why do I have like 1500 packages? Let's just ask our trusted friend ChatGPT. I guess that I would have to sign in. Oops. Bro, come on. Okay, thanks. Just created a new Unity project and already have an error. Code is first when you try to access the name of the script and the line number. It just disappeared. Okay, it just disappeared. Oh no, it didn't. Wow. Okay. It's from the pack. from the package cache, collab proxy plastic. Let's just copy this one. What is this package? Plastic. I don't see a plastic package cache. Is there plastic? Bro. Take your time, ChatGPT. No worries, bro. Holy shit. Collections generators dictionary. Niklas, line 42. Yeah, I guess that. Cloud project downloader. Do I need this cloud project downloader? Hey bro, I don't know how to look at the line of code. I also don't know why I have like 15 packages. Do I need them? Okay. Packages installed correctly. Okay. Bro, come on. I probably can't check the line 42 of a package. And I probably shouldn't change the line of code of a package. And I probably even can't. So... Classic SCM problem. Sounds... Okay, that sounds pretty good. So restarted the program and it worked with no errors. Unity latest version giving this error. Okay. Let's just save and restart. Maybe this fixes it. Hopefully. Closing and restarting a program to fix an error is such a programmer solution, and it actually works. This is so dumb. Okay, let's hope maybe now it works. And I still don't know why these things are not prefabs Okay, now they are prefabs. Okay, I think it just was completely broken. Okay, just drag 3 of them in here. Move them a bit. Like this. Create a new level object. Move them into there. Create a player object. 0, 0, 0. Y a bit higher. 0.5. Move the sun up a bit. Okay, I think we're back to where we were before. Yeah, I think we're back. Okay, let's continue. Okay, but wait. I'm saving and now hitting play. Please don't reset again. Oh, thank God. Okay, and we didn't add the rigid body. Okay. Thank God.
Not a fun game because we can't do anything. But at least we fell from the sky.
Bro, I exit. Okay, now I'm out of play mode. Okay.
And hit the ground. So we finally got some. Movement in our game. Isn't that amazing? We still can't control it.
Just to restart the program. And everything works again.
So it's not a game, but
so
at
dumb.
least something moved after all this talking. So what this rigid body thing is doing now, it's got a mass of 1 kilogram, it's applying gravity, and it's pulling this capsule, our player, down towards the ground. And this capsule collider is colliding with this box collider. And when it's doing that, it's preventing it from pushing through this box collider. We can actually switch back into the scene view now. You can independently go through the game view and the scene view when you play. You can even drag this one out, actually, if you want, and look at them at the same time. That's perfectly fine.
Oh, interesting.
Let's keep it there for now. So this capsule collider, you can even modify it here. We're still in play mode, as you can see up here. And if I drag this capsule up, it'll drop it down. Drag it up, drop it down. Drag it up. If I drag it to the side,
no way,
it'll fall over. So that's pretty nifty in Unity. You can actually modify the game scene as you're playing the game. If you want to test something, you can reposition it. And,
okay, when we change something in play mode, I guess it's not saving, and I will now always save before hitting play, because I don't want to reset everything again. Bro, I can't. Wait, what? I can't pull this one up.
Without.
How does he do that?
At the same time, that's perfectly fine too. Let's keep it there for now.
He's in.
So this capsule.
Oh, he's in scene, and now we can. I see. Okay.
Collider. You can even modify it here. We're still in play mode, as you can see up here. And if I drag this capsule up, it'll drop it down. Drag it up, drop it down. Drag it up. If I drag it to the side.
Oh shit.
So that's pretty nifty in Unity. You can actually modify the game scene as you're playing the game. If you want to test something, you could reposition it and without having to stop and start the game. Just keep that in mind. You can modify
this guy is also falling.
in the scene view as the game is playing. And you can also pause a game.
But you don't see my cursor.
Let's restart it here.
But you saw the position just dropping lower and lower.
And then I pause it here. I can still move it to here and see, okay, I want to have this one, if I can hit it there. And then, yeah, I'm pretty happy with that. Let's unpause it and see what happens. And that's useful to know as well.
Oh, okay, I see.
And also when you come out of play mode, it'll reset it to the way everything was before you pressed play, because you don't want the game to remember how it was when you stopped the game. Like the player dies, for example, you want to have everything reset. So Unity also does that for you. When you press play again, or the stop button in that case, it'll reset everything to the way the level starts, or the scene starts. Just to remember now, before the days of Unity and the other game engines, there wasn't such a thing as a built-in physics engine. If you wanted something to fall down to the ground, you first had to code the part that applied the physics to the game. So it's become a lot easier nowadays, luckily enough, to make games, and we can focus on
God bless IDEs
instead of coding a physics engine. But maybe that's something you're interested in, so that could be fun as well, obviously. Okay, side note. Okay, now we're going to be adding some user input. So for a game to be fun, we have to have some form of user input, and that's going to involve some scripting. Are you still with me? Don't worry about it. If you haven't created any scripts before, or if that's been scaring you off all the time, don't let it scare you off, because a script can be very, very simple and easy, and you can learn more and more as you go along. That's how I learned scripting. I started to think, actually, this is exactly what I did the first time I tried to make a game. I wanted something to happen. So I created 2 boxes, and I wanted one box to hit the other one. And then I just gradually increased my scripting skills that way. So don't be afraid. We'll get through this. Don't worry about it. You'll repeat it. You'll learn it. And you'll get there. So have I convinced you to continue now? Let's continue. So we're going to do something at a very basic level now. And I recommend using C#. That seems to be the most common scripting language that's used in Unity. And it's also very versatile and useful in other cases. So I recommend that you learn that one. A lot of stuff that you
or at least I heard it's pretty easy.
Will return results for C# scripts for you. There's also JavaScript. I used to start with that one, but I've since long switched to C#. I find that one to be a lot more better.
A lot more better.
Okay, so now cast your scripting fears away, go to the root asset folder here, and in the empty space, let's right click, do create folder, and let's call it scripts. And double click on that one to go into it. And now let's right click in the script folder here and create, and this time we're going to do a C# script. And let's call this one player. And press enter. Unity will keep the extension here, as you can see, but here in the view, it'll just show you the name of it. So we've got our first script created now. Okay. We can double click on this script. Here, actually, I should mention as well that if you go to Edit, Preferences, then you'll have external tools here. And my external script editor is Visual Studio.
Wait, what?
Actually, I should mention as well that if you go to Edit, Preferences, then you'll have external tools here, and my external...
Okay, now it's working. But you don't see that. Okay. Doesn't really matter, I guess. External tools, external scripter, Visual Studio Code, yeah.
Studio 2019 community, and that's free to use for anyone. But I think, oh yeah, maybe that's all that is supported nowadays. It used to be mono, but maybe it doesn't come with that anymore. I recommend that you use Visual Studio anyway. It's a great editor. So when we double click on this script.
Wait, what did he have there? He had embedded packages and local packages. Okay, sure. And editor attaching. But I can't check that. I don't have an editor attaching. Oh, okay. Should
recommend that you use Visual Studio anyway. It's a great editor. So when we double clicked on this script and it loaded in Visual Studio, you're actually looking at the first script that Unity creates by default. And again, don't be...
Oh, you don't see that. How do I install recommended extension for C#? Sure. Yeah, trust. How do I do this? Because you probably need to... I'm just dragging it over it. Give me a second. Where is it? Window capture. Use code. Use code, yeah. Capture cursor, client area. Looks good, but I need to... Try to save it. Something like this. Okay, no, not something like this. Okay, give me a second. Okay. Oh, never mind. I just forgot to fit it to screen. Fit to screen. Now I can. But why is there a gap on top? And install this C# package things. Okay, something like this. And then something like this should probably work. Yeah, it looks fine, I guess. Drag it onto here. Okay, perfect. Player.cs.
Don't be scared. We'll go through this and you'll nail it.
Nah, it's fine.
If you know what this default script is all about, just skip forward. But for those of you who've seen a script for the first time, I'm actually going to go through this with you. But I'll timestamp everything in the description so you can fast forward to other sections if you want to skip ahead. So I'm going to start from the top here. And the first thing that we see here is this keyword called using. And it says using system collections. And it says using collections generic. And it says using Unity engine. And this is something that's called declaring the namespace. And again, you don't really have to learn this in much detail, but I'll tell you anyway, because I want to leave no stone unturned in the first thing I do in a new script here. But if we have this using Unity engine here, it's just telling the engine, or it's telling Unity what namespace to use. Just to demonstrate, if I were to take this line away, let's just delete it. You can see that something happened here. This one turned red squiggly. It doesn't understand mono behavior. Okay, what's that? And that's because that was hiding in this Unity engine namespace. And what that is basically, it's a collection of lots of stuff that you can do in your script. So it just knows to look without having to type it. If I were to type in here, Unity engine period, then it finds it.
Okay.
But you don't necessarily want to have to type this all the time. Unity engine period something, Unity engine period something, Unity engine period something. So that's the whole reason for this using statement here, using Unity engine. And as you learn scripting, you'll find that you want to bring stuff more into this using stuff by adding, maybe you want some UI stuff, for example, that would be needing to using the Unity engine.ui, for example. So again, don't be afraid of this. It's just here to make the script a little bit simpler, and just keep these as default for now. The second thing I should mention here is the semicolon, and all the lines in C# ends with a semicolon, and that's how you differentiate from a new line. And just as I say that, I realize that not every line ends with a semicolon, because when you have stuff down here, like a method, which is a function, then it doesn't need this, but every command inside this function will need it. So you'll have to get a little bit used to when to use it and when not to use it.
Also depends on the programming language. There's some programming languages like Swift. Yeah, like Swift. That completely don't need these semicolons, and then there's like Java, for example, where you need it everywhere. And C#, I guess
you're going to have to put a semicolon at the end, and that's
like he says. And C# is also pretty much everywhere you need a semicolon.
Mistake when you write code later on, you'll find that you've missed it. But luckily enough, the script will often tell you that, oh, okay, here's your line of code, and you'll usually find it fairly fast. So with the semicolon, you could theoretically do this. You could actually move this line up to here and this one up to here, and it will still work, the script, because the semicolon is what's telling that it's something new is coming. It's not the line feed itself, but it's not very common to use it like this. So let's just keep it like this. You want to separate the lines. It's very rare that you have multiple things on the same line. Just keep it tidy. Okay, so the next line here, we've got something called public class player : mono behavior. And a class is basically a collection of variables and functions that the object-oriented language of C# can use to create stuff. Let's just keep it simple as that. We don't have to demystify it more than that at the moment. But remember when we created this script, we named it player, and Unity automatically named the class player here. And we don't have to worry about this too much more now. Let's just keep it in mind now that we can, in this class, inside this class, we can have different types of variables and functions to store values, and we can have some functions to do stuff like jumping or moving. before we move on now, we should actually add this script, which is also a component to our player. I minimized Visual Studio here and back into our project folder. I'll take...
Wait, like this, okay.
Take this script now, and I'll click my left mouse button, drag it onto the player here. And that automatically adds this one. If we select the player now, we can scroll down. We see we have the transform, the mesh filter, mesh renderer, capsule collider, rigid body, and here, pow, a new component. And this is our player script. And what's important here as well is that the name here of the class needs to be the same as the C# script name. Let's say you wanted to change this one, and it was called hero instead or something. Control S to save it.
Okay.
Now when I go back here, we can see here that it's shouting a little bit. We've got a little exclamation point. The associated script cannot be loaded. Please fix any compiler errors and assign a valid script. And keep in mind, if you get some error like that, it's because the name here of the class needs to be the same. Player. And if I rename that one, press Control S, select the player again, we can see that that error has disappeared. If you did want to rename the script on the class, click here on the class name, press F2, which is the shortcut to rename, and then type it in here instead. You can see that it turned a little bit cyan colored or light blue. We'll type hero there when we pressed F2. Remember that.
Yeah, and then it just renames the whole thing.
Go back into Unity, you can see that it'll do some work, and it actually re-imported it. It renamed the C# file now to hero, and everything works again. Does it work then? The player now has the component hero instead.
And also gets renamed in the script. I see.
But let's go back. We wanted to keep it named player. So F2 again and press enter. Okay, so we've got one more thing on this line that we didn't demystify yet, and that's this :mono behavior. What the is that? So a class can inherit something from a parent class, a little bit like the game object, the child grass game object that inherited the location of the parent, for example, and then applied its own little custom local location. But in the same way, this player class that we've just created is inheriting from something called mono behavior. And mono behavior is Unity predefined. It's a whole bunch of toolkits that is contained within this parent class. It'll have so many things. When you look in the Unity documentation later on, pretty much anything that you can do in the scripting language that's relating to Unity specific things, it's inherited through this mono behavior. You could also have classes that don't have this inheritance, but then you'll lose out on all of those nice features. And as I mentioned before, when you create a default script, the mono behavior here is by default. So let's just keep it there and see what it can bring us. And then we have this squiggly bracket. And when you've defined a class like this, like our player class, it has to start and stop by these squiggly brackets, open bracket and close bracket. And now we get to something called a method here. So we've got something that was also pre-configured here. It says void start, open, close, normal bracket. And this is called a method. And in other programming languages, it's usually called a function, but the C# name for this is a method. And this line was also included kindly by Unity, and it says start is called before the first frame update. And here is actually something that this mono behavior now brought us. Since we're inheriting from mono behavior contains a whole bunch of these type of methods that we can use to put our script code in. And as it says here, this start method will be called the first thing basically when you press play and we have our capsule now, our player created here, it'll run this automatically. Whatever is inside these squiggly marks here of this method, it'll run that piece of code and it'll only do it once. And then it'll move on. And usually when you create a method, it doesn't have this automatic run feature. That's something that's quite specific for Unity now.
I think it looks better.
If you had created your own method here, let's call jump, for example, like this, then this one doesn't get called automatically by any means. It's just there. So it's a bit tricky sometimes to know which ones are Unity default or which can you have. And that's when you have to revert to the Unity documentation. But I'll cover the most important ones in this video as well. And then this void thing, what's that all about? And the word void means nothing. And this is what the method or function will be returning. And it's not, if it says void here, it doesn't return anything. And by default,
you need to write it first there.
That comes with the mono behavior, it doesn't return anything. So that's why, and it also has to have something. And if it shouldn't return anything, you have void. if it should return something, it needs to be stated what type of information it should return. But we can get into that later on as well.
Yeah, just different. What's the name? I don't know. Just how you write it. Because in Swift it would be something like this: start and then just write nothing or return void. But here it's just at the beginning.
And the next thing we have here is another method that comes by default with this mono behavior, and that's update. An update is a method that's called by Unity automatically every time the frame.
Okay, I have something I want to check. Do you need this public? Probably. Okay, I'm not messing around with it because you probably need this. I don't know what the default. I forgot the words. Which they are called, but you have like different access, something with access. What can access this class, and here it's public, but I don't know what default is. So you could just remove it, and it's probably internal. But let's just leave the public.
Is rendered. So once every frame, it'll go through this for all of your scripts or all of your game objects that have different components. It'll find this up.
Recording is paused. What the heck? Bro. What is this? Stop. Okay. My cam. Bro, I don't want to type something. Give me a second. Style. Text overlay. Okay, now we're back. I don't know what Logitech Capture wanted to do there, but
execute whatever piece of code is in this update method.
Do we have enough? Will probably be fine, I hope. But I should check my disk space from time to time.
And it'll do it once during that frame, and then it'll leave it alone. And when it comes back next frame, it'll do it again and 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 again. And it'll just keep going like that forever, pretty much, until you run out of power. So the frame rate actually will depend a little bit on how your game is configured. And usually it runs about 60 frames per second, but if you've disabled something called VSync, if you've ever seen that in a game, maybe that's disabled, then it could theoretically run 1,000 frames per second if it's a really simple game. So the number of times this is called, you can't rely on it being a specific value every time. So you have to keep in mind now that when we put code here, if you were to say that it should move 1 unit distance every update, then on a really slow computer, it'll move
pay to win that
based on the frame rate. On a really fast computer, it'll just shoot off screen because it rendered 1,000 frames and it moved 1 unit. So that's something we'll keep.
Just in a shooter, shoot once per frame. And the guy with like 1,000 FPS is just demolishing everything.
In mind a little bit later on as well. And finally, again, just the
once per frame
bracket is just saying
completely
now,
nuts anyway.
Method called start, and for this one called update, we have a beginning and an end. So the code that we put within these squarely brackets here is what's going to be executed in this method. So now we're finally going to write our first line of code, and what we want to do is something called an if statement and check if you as a human player if you're pressing a jump button, we want our little capsule player to jump. That's our objective for now. So what we're going to create is something called an if statement. And that's very common in many programming languages. Also, we want to put that here in the update because we don't just want to check if you jumped at the beginning of the game. That wouldn't really work. So we have to check for this jump button in every frame. So in this update method, that's where we need to put our code. Because we want at any time in the game, the player should be able to press jump and the player should jump. Let's just put this in as an example. So if in real world, for example, if you're hungry, so if hungry equals true, then you would do something, you'd eat. So now this code wouldn't work, but I just wanted to put as an example. An if statement is if something is something, then do something.
Okay, you need these brackets. Interesting.
Then eat. So that's something you do in real life. That wouldn't work here because we need to check for an input instead and do something in the game. For this example to work, we would need something called a variable. And this, if you want to check if something is true or false, the data type of that variable is a boolean or a bool. For this example to work, just to make sure I don't leave any stones unturned, like I said before, we could have declared a variable here of the data type bool called hungry.
Okay.
So if you put something that's not inside one of these methods here, I put it at the very...
Also interesting because in Swift you write like bar or let, depending on if it's changing or not. And then let's say hungry as the name. Bro, I still don't want to type something camera. Come on, mate. And I still don't want to record. Okay, let me just check. There needs to be some start stop. Bro, just don't start and stop. Click pause, toggle mic, toggle system. When did I press Alt and T to toggle text overlay? I didn't press Alt and T. I don't know, mate. Let's just hope this doesn't happen again. Okay, back to... I'm explaining how this in Swift works. It was hungry and then you write like boolean? No, you write bool. What did you write for a boolean? I think you write bool. I do not. Bro. Stop trying to record. I'm not pressing Alt. I don't know. Anyway, it was like either you write bool there and then set it to like true, or you could just set it to true and Swift knows it's a boolean, or you could, if you want it like that and initialize, a few different ways. But okay, interesting.
Very top
there you write it.
I declared a variable called hungry, and it's a bool data type. So it's not a number, it's not a piece of text. A bool can only be true or false. And see how, when I typed in here bool hungry, which is declaring this one, then the if statement, suddenly the red lines here disappeared because now there is such a thing called, there is a variable that's called hungry. And we can check if that one is true. And you might ask, why is there 2 equal signs here instead of just 1? And that's in C#, if you have 1 equal sign, it's actually setting this variable. So it would set hungry to true. And we don't want to do that. We want to check it. And the syntax for doing that is having 2 equal signs. So maybe a little bit confusing at first, but you'll get used to that one. So this one is still squiggly here. It's called eat. And that was a method that we
seems to work as well.
So I'd have to declare.
So you don't need these.
And here's another thing, actually. You could type it like this, void eat. And those squigglies will disappear now because there is a method now. If the variable hungry is set to true, then it would call this eat function or eat method and execute whatever code is in here. But there's actually a nice way to do this as well, I should mention. When this one's red squiggly like this, in Visual Studio, you can press Control period. And then it'll give you some nifty options here. It says generate method for player.eat. So if I click on that one, it already declared this one. It actually threw out some more code that we don't necessarily need. Private is to say if only this script should be able to access it, or if another script should.
Okay, wait, I could just make it a bit bigger for you to read it. Just so that it's probably too tiny for you guys to read. Should be better now.
Should be able to call it. That's why the difference between private and public is.
Or there isn't.
By default, it's not typed there. It is private by default. And here as well, when it auto-generates it, it just creates a line of code to throw an error. It creates an error that it's not been implemented yet. But it's very common in Visual Studio here that you can use the control period. We could have done the same here when we wanted to declare this variable. We take this one away, so we're back to here. I click on this hungry here, I press control period, and then it says generate field. Actually, the proper name isn't variable, it's called a field in C#, but it...
Control S to save? Probably control... How do I save? Because I just removed eat and hungry, and these are both not underlined.
If you hear variable or fields, it's usually the same.
But how does it do this?
We take this one away, so we're back to here. I click on this hungry here, I press control period, and then it says generate field. Actually, the proper name isn't variable, it's called a field in C#, but if you hear variable or fields,
no code actions.
Pretty much. So we can generate the field player hungry, and you see, it declared it as private. It was the bool. It knew, since we were checking if it's true, it knew that it should be a bool data type, and it knew that it was going to be called hungry. So again, we're not going to check if we're hungry. We're not going to eat. We're going to check if the player should jump. So let's make something real, should we? So if I press space
Sounds
now,
good.
I should be able to jump. So space. Jump.
Nice
so
one.
let's do that in code now.
Okay, let's try if it works. Actually works. Let's go.
Now, since we needed to do check for this all the time, we have to type an if statement that we just learned a little bit about, and we have to open it with a bracket. So now we have to type the code here. What are we going to type?
But do we need to?
We're going to check for something called input.
I don't think we need to open the bracket.
Something here. If I start typing now input, you can see that it's actually suggesting here a bunch of things. Usually when I want to
suggesting anything.
I Google it. Let's see, I want to check for input. I Google Unity C#.
That's programming. That's programming in a nutshell right there. You want to do something, you Google it.
Or something like that. And then it'll give me a bunch of things, and that will direct me to either some sample code or the Unity documentation. And it'll tell you a lot of stuff, how to check for input and how to do it. And as you learn this, and I Google all the time, pretty much every day as I type code, I have to Google it all the time. I have to go to the documentation back and forth. But gradually you'll learn more and more.
Programming is just finding things quick.
And more. So we're going to type input here.
Dot.
And then we want to check for something.
Bro, it's probably because this... Bro, but it's enabled. Why don't I get autocorrection? Oh, okay. Do I get... No, I still don't get it. Ah, whatever.
And if I press period now, you can see that we've completely typed here, but if I press period, it's got some more stuff here. We can actually start reading what we can check for here. Any key.
I can't.
Any key, like Homer Simpson would have pressed. We can either scroll through here and see what there is. There's a lot of stuff here. Let's see. Get access. What could that be? Maybe a joystick. We've got get key. Get a key press. We have get joystick names. Key down. Mouse button up and down. You see, Visual Studio will give you all these things just for free. So we want to check. What did we want to check? We wanted to check for a key. Let's make space the button that we need to press for jumping. So get. Is there something called key? Yeah, key. And should it be on key down maybe? When you hit spacebar, then we want to check that one. And now it's out of suggestions here, but it gives us something here as well. So get key down. Then we have to provide something called a key code. So what could that be? I press bracket again as it was expecting, and it's already suggesting here key code. Okay, so let's double click on that one. And it was space, so maybe we press period again here. Oh, it's actually suggesting a bunch of key codes. We can scroll up and down here with the up and down arrow.
I'm just using the bracket now. I don't know if it's because of that or not.
Yeah, we can. Space. So just by knowing that we wanted to check for input and we wanted to check for some sort of a key command and we wanted to check space, the combination of the
input, get key down, key code space, I have exactly the same.
Type what you need and also Googling what you need. will help you along the way to find out what you wanted to do. And all we wanted to do was check for a space key to be hit. And this is what we ended up with. And we wanted to see if this one is true. So equals true. So if get key down, and that's actually the down action. It's not if it's pressed all the time. If I would have just typed input.getKey instead of get key down, it would actually return true every time as long as I'm holding space down. But if I'm only checking it on the key down action, it'll only do it once. So if I hit key, even if I hold it down, it'll just jump me once. And after you have checked an input, remember we needed to have the squiggly open and close bracket here. The only reason why this input actually existed in the first place, again, is because we've got this using Unity engine. So if this one wasn't there, press Ctrl S, see, it has no clue what we wanted to do. So all of this is very Unity specific, and it's requiring this using Unity engine. Then it knows, ooh, I'm going to look in the Unity engine. I'm going to see, okay, there's an input thing. We can handle the keyboard input.
Using system.
Check for key downs.
I don't have using system.
Joystick, mouse, you get it. We could improve this code a little bit more as well, because we wanted to check if this one is true. And if you wanted to check input get key down, this is, we can see it as well here. It's a bool. Remember, we learned what a bool was. Could either just be true or false. But when you write an if statement, you don't really need to write this equals true, because it's expecting that. If we want to check something, it just expects me, okay, do I want to check if this is true or not? So we can actually take equals true away and keep it the code a little bit smaller. But in theory, it still says the compiler will still interpret this as saying equals true. You can keep your code a little bit tidier if you just want to say if input get key down, key code space, then do this. And what I mentioned before as well, when we started to get all these freebies with what to type, that's called IntelliSense. Let's see how far we can take this. How much code do we actually have to write to make this thing? Let's take it to the extreme. So if I typed I wanted to create an if command. Okay, so it's already, see here, IntelliSense.
Oh, okay. It really was this using system. Now I get the autocorrection. Okay, good to know.
Top choice here, since it's so common, is if. I press tab. Okay.
Oh, tab as well.
And then I'm going to enter an open bracket.
Tab works as well.
And we wanted to check for input, right? So I press I, N,
input,
P.
For me,
now
input.
We've reached as far as to say the top choice now is, it knows that we probably want to type input. So I press tab. Okay.
Take it key down.
Period. And then we wanted to check for get key down. So we press G. Oh, see, it's already at the top. And the most common thing to check for input is actually get key down. So I don't even have to type that one. I can just press tab again to accept this top recommended thing here. And then I do another open bracket.
5 things.
See, it's already checking. Okay, we probably want to check a key code. It's the top choice here, or the highlighted choice. So I press tab again.
Didn't actually
space. So
okay, no, P, I don't get this.
And S, P, and then it's suggesting space. And then we do.
Wait, how much was it? Was the I? It was this bracket 2, 3 for the I. 4, 5, 6, 7, 8, 9. I mean, 9 keystrokes for this line is pretty decent.
Squiggly marks. So, how much code did we really have to type there? We had to type, let's see, I, 9. tab, capital I.
Okay, tab. Actually, tab, so it's 18, I think.
Open bracket.
No,
tab,
it's not 18,
period,
it's 16.
Space, tab. Close bracket.
No, it's also not 16. So, wait, give me a second. 17, 15, 16, 15, 14. It was actually 14. Okay, 40 keystrokes.
Keep in mind that IntelliSense is really useful. It'll often give you hints on what to type or what it expects and things like that. So don't just ignore that advice. See what comes up when you start typing things. See if that's what you're after. Press tab to complete it, and use those hints to help your coding a little bit along the way. The beautiful thing with this is that you don't have to memorize the code. You just have to sort of know what you're after. And in the beginning, it'll be a little bit tricky. But as you get more and more used to it, you just have to sort of know what you want to do and start typing a little bit what you think it is. And then hopefully this tab and IntelliSense will help you along the way. And again, combine it with
pretty good advice.
How do I check for input in Unity? How do I make a player jump? How do I make...
And nowadays also ChatGPT could help you. From my experience, ChatGPT does help with like simple things if you use it in programming. So it could actually save you some time. But if you have more complex things you want to code, then at least for what I did, ChatGPT was like kind of at its breakpoint, I guess. So didn't really help there, but
how do I,
it's useful.
Just think of stuff to Google. Google is your friend, hopefully. But we don't want to check this twice, so let's delete that one. That was.
And yeah, if you don't have an answer from ChatGPT, you could use Stack Overflow. That's a pretty big forum for like coding questions. That's really, really useful. I've got a lot from there, and you could also use like the default, for example, C# documentation. There's probably from Microsoft C# docs, and you can also read there what you can do or how you do it, and it's probably pretty easy. I just type how to get space input C#, probably something like that, and then yeah, here first one, Stack Overflow, input that get key. Okay, actually here it's get key space or get key code space. We got get key down key code space because we only wanted once, but you don't always get like the accurate answer, but it's pretty decent. It's pretty good.
Example,
and I could probably, and I could probably have written it a bit more precise. Where were we? Like here? Something? Okay, no. Where was it? Something
Why
like
are
here.
You doing something? Maybe you've done something that looks a little bit off.
I think it was
maybe
something
like
here.
Maybe make this one clear before, but these double slashes here is a way to document your own code. So if I press enter here and do // we can actually write something. Let's call check
comment
space key is down. And these are basically just hints in the code or documentation in the code, either for yourself or for your teammates if you're writing code for someone else to be working on as well. And I wouldn't suggest going overboard either. You don't have to type comments for every line of code, like check if space key is pressed down, because it's very apparent here that we're checking if space key is pressed down. But know that you can write these type of comments, and often you want to use these.
Yeah, it's pretty good if a class or function is more complex, and you can like just write what it does, or maybe if like a part is pretty complex, but sometimes you have it like here. I mean, you could basically read this and get that you check if the spacebar is pressed. But sometimes these aren't called as precise or aren't documented as precise, so you could use the comments for them.
These comments when there's something that maybe it's not so intuitive,
but true,
like
here,
why are you doing something?
Here it's not really
maybe you've done something
important.
That looks a little bit awkward, or why am I doing that in this update loop, or why am I doing this? That could be
like he says.
Often try to get the code itself to document itself, and if you need to add stuff,
that's a pretty good tip he just mentioned. Get the code to document itself. So if you, I mean, here we got them from outside code, from a package. But if you write your own code, just try to write it that someone could read it potentially. So like a sentence. It's not really a sentence, but as close to as what it does as you can.
Like here, Unity has added this. Update is called once per frame. It tells us something. Okay, so this is just not any method. This one is actually called once per frame, so that's a useful message. This one is not so useful. It's also very important where we put this line of code. So this if statement now, when we did check for if key down, that's actually only valid one frame in your entire, when you're playing the game here, it runs through this update loop over and over again. And the moment that you hit space, the key down here, it's actually only reported once on that frame. And then it's not going to be reported again until maybe you release space and press it again. That's the second time it'll hit this line of code. So that's why it's important to know that you have to capture it in this update loop. Okay, nothing is happening now. If we press play, let's press Control S. If I were to start the game now, nothing would really happen because we're only checking if the key down is pressed and it's actually hitting this line of code, but nothing is happening. And we can make sure that we write maybe something, a little hint to see, is this working? We can do something called, that I commonly do, is it's called a debug log message. So let's type debug, press tab on the on, period, log. I suggest we just want to put a log entry here. And then let's type here, space key was pressed down. And then remember, we have to end it with a semicolon. And strings have to be in these quotation marks here as well. So this is, again, something that Unity has, and it's called a debug, and a function here or a method called log, and it'll send this string here now to our console. And we haven't covered the console, so let's minimize this. We'll press Control S to save it, minimize it, and here's a console. It's also here down at the bottom. Okay, you have to toggle away from the project window here. You could also drag this one down to the bottom if you wanted to have it visible at all times. But now we press play. We see that it enters here, and we press, let's see what happens. We press space, and nothing happened because we haven't told the game object to jump yet.
But we
did get this line of code that we expected. The debug
you can't see it, but wait 1 second. You can just turn off the cam, you see it. You see it here. If I press space, there's a message.
Happens here in the console. Even if I was in this project folder, it shows the latest line of the console down here at the bottom. Space key was pressed down. So we know that Unity is hitting every time I'm pressing this line out.
Could probably put the camera a bit down. Yeah, that's better.
Let's see. Yeah, and you actually have to make sure that this game view should be active. So if it's not updating, maybe you have to click in the game window here to make sure that it's actually active. And then when we hit space every time, it'll log this message. Okay, but we didn't want to log an error message every time we jumped, or a log debug message. We want to make the player actually jump. So let's do that. So let's make the player jump, really. So now we need to take this log message away. You can either erase it with backspace, or you can press Control Y to delete the entire line. Let's think now logically. What needs to happen when we press?
No, I can't press Control Y. This doesn't work for me. But let me check. VS Code delete line shortcut. Oh, it's Control X. Yeah, okay. Because of American. And wait, no, it's not because of. It would be Z then. Okay, maybe it was an update or something.
Space. We've checked for the input. We press space, and we had something called a rigid body. Remember, that is applying physics to make the player drop down to the ground. So there's something going to do with physics or rigid body. So we have to actually access the component now, the rigid body component. And here we can do that. You can access any component. Let's minimize this. Remember now that this player game object has this player component, or the player script. And it also has this rigid body component. So somehow we need this script to be able to access this rigid body. We need to get this component. And there's actually something called just that. So here we want to do get component. And then inside these sharp angles, greater or less or greater than signs, we can type what type of component was it that we needed to get. And it's the rigid body. So I'll stop typing and there it's got it. So I press tab to complete it. And then when you get a component like this is actually a method. So we need to have these empty brackets. So, and that's the syntax to get.
I still don't know why I don't get these auto corrections. But he does.
Oh, you can press period to see what can we do with this component. So we've got the access, or we've got a reference.
No, I can't.
And when I press period, there's lots of stuff again. Lots of magic stuff we can do. Okay, what is there? Move position. We've got velocity. That's probably how fast it's moving at the moment. We can add force. We can add explosion force. Cool stuff. We can, let's scroll down. We can change the center of mass on it. We can probably change the mass itself. Let's scroll down and see. Remember that was 1 kilogram in the inspector. So we can actually set it here to something else if we wanted to through program. But what do we want to do? We want to add a force probably to make the player jump up. So let's type add force. Okay, so when we press space, we want to get access to the rigid body component and we want to add a force. So far so good. Open bracket here. And then it suggests we need a vector 3, a force, vector 3. So a vector 3, what is that? That's something that has got a direction and a magnitude. So it can point in some direction and it has how large, or what's the magnitude of that force. So remember now, the x-axis is left and right, the y-axis is up and down, and the z-axis is back and forth. And that's how Unity's coordinate system work. And when you jump in this case, which direction do you think you want to jump? So, okay, we probably want him to jump upwards. You could probably run and jump forward as well, but we want to apply the force upwards as you jump. And luckily enough, there's actually a predefined vector already. So we can type vector 3 dot up. And that would take, and by default, this up, as you can see, shorthand for writing vector 3, and then in brackets here, 0, comma, and then the y component is 1, which is up 1 unit, and then 0 on the z-axis. Okay, we're going to apply the up force, but then if we type comma again, we see if there's something else we need to provide, and there's something called force mode here, and we have to pick the right force mode. So if I press tab again, okay, let's see, if we press period, it'll suggest what type of force mode we have, and we have acceleration, force, impulse, and velocity change. And here for acceleration, add a continuous acceleration to the rigid body, ignores its mass. Force, add a continuous force to the rigid body using its mass. We've got impulse, add an instant force impulse to the rigid body using its mass. And velocity change, add an instant velocity change to the rigid body ignoring its mass. So now we can just use mass or not. Is probably appropriate for us. We don't probably want to have acceleration because we don't want to accelerate it up. We just want to make it
probably force, right?
Also force, it's using the mass. So it would basically jump different heights based on what the mass value was set. So if it's 1 kilogram, 100 kilograms, and for our simple platformer game, we don't want it to have really pay attention to how much the player's weighing.
Okay, fair.
So we probably ignore that one. Impulse also uses the mass,
velocity change.
We probably just want to do a velocity change here. We'll instantly set the velocity to something, and then we ignore the mass. So let's pick that one. Let's try this. So we have to end this line out with a semicolon. Remember, I press Control S. So let's see if this works now. We press play, and then we jump. Oh, okay, it's jumping, but not.
Okay, interesting. Wait, let's check if it also works for me. Come on. Let's spam. Oh, I can spam space. And we get a bit higher. Okay.
Not very much.
But not that much. Oh, okay, so wait, what? Did he just fall? Did my guy just fall down?
The force, the magnitude of this vector up is not enough. It's adding a velocity change up, but the gravity is capturing us way too fast and sending us down again. So let's go back and multiply this. We can actually multiply it by 5, for example. Press Control S again to save it. It's important to Control S to save every time. Otherwise, Unity won't really know that something has happened. Press play again and press space. And now we've got a jump. That's a pretty decent jump, but we still can't steer anywhere, so it's not a fun game. Oh, and here's another thing. You can multi-press. So air jumping, probably not what you want to do. It's like a rocket landing game now suddenly, and it's tilting as well. So is this a game yet? No, it's not.
It's even though early stages of Flappy Bird. Bad Flappy Bird.
We've got user input. We can't really do anything about it. There's no goal. We can't achieve anything. There's no challenges for us to conquer. So we have to work a little bit longer on this. It's time to make the player move a little bit, not just up and down, but left and right. Let's make it move along our little platform level here. We'll use the keys A and D to move left and right. So those are the common AWSD keys. I'm supposed to be saying WASD, but I say it AWSD, but it's the WASD key setup. But we'll be using physics to move this as well. You could move it without physics. You could translate it in scene. Some games will just have translating, which means moving the object left and right. But since we've already got some physics going here with the up and down movement, we're going to stick to physics to move this little platform guy of ours. So we have to say hello to another mono behavior. So we've got start and update from before. And there's another one called fixed update. And unless I told you so, you wouldn't necessarily know about that. But again, the Unity documentation will tell you a lot of the existing methods that are already predefined in the mono behavior. But for now, let's do void. Remember, because it's not going to return us anything.
Oops.
Fixed update, and it's suggesting here. So let's do tab. And it's already defined this one. And we could have left the private keyword out, but it stuck it in there for us. So let's just leave it for now to keep it extra obvious that this is only going to be executed within this little script of ours. And fixed comment is a little bit different from update, where it's very different. Even though it runs frequently like the update do, let's put a little comment here to make it extra clear for us. So fixed update is called once every physics update. So what does that even mean? So by default, Unity runs with a physics engine that updates 100 times every second, so at 100 hertz. And what that means is that the physics engine will update everything in the world 100 times per second. Even if let's say you're playing on your grandparents' computer and the game's running like at 5 frames per second, then that's the physics engine will still update as if it was running at 100 seconds. So anything that's falling, like with gravity, for example, will still have the appropriate speed, even though it's like a slideshow because their computer is so slow. Then at least you know that the physics...
Imagine you just fall slower because you have lower FPS.
...is reliable. It'll still update the way it should. So the difference here would have been like, again, on your grandparents' machine, it's running update once every 5 seconds because it's like a graphics card from 1984. But then the physics update will actually run so it keeps in sync with the proper physics. So I hope that makes sense. So by default, it's 100 times per second. And again, you can customize this in some games. You might want to increase the frequency and you can change that in preferences, but we're just going to stick to the default of 100 times per second now. And here's something very important now. Remember when I told you about this key press here, the get key code down, then it's checking for space. And that's only true once every frame, but that's actually every rendered frame. So we could actually miss it if we stick it here in the fixed update. And that's a common mistake to do and very confusing probably. So remember, anything that is registering a key press or a key stroke or a mouse click, you need to have that one in update because you risk missing it in the fixed update. So keep that in mind.
Okay.
And at the same time saying that we're actually applying physics now in the update loop, and that's not really good practice either. So we have to change that one as well. It works, and because we're adding a force when only once, and we're adding a velocity change, then it was sort of okay, but it's not good practice. So we have to fix that. I can't start your first script by breaking a principle. So we have to change this. So there's two things we need to consider here. The key press needs to be registered here in the update loop, but the force should...
Break principles in the first tutorial, basics tutorial. Let's go.
...really be applied here in the fixed update. So before we start with the left and right movement here, let's just fix what we did here. So we have to set a little memory here now. So when we hit the keystroke of space, then the computer code here needs to remember that space was pressed, and then it needs to do the change here down here in fixed update. And remember I told you about that hungry variable? Well, we're going to apply something similar here. Let's go to the top of this class now, and we're going to declare our first proper field or variable. The proper name is field, but you'll hear variable a lot. And it's going to be a bool type. We only need to check if it's true or false. And up here we type private. Okay, and we could really left that one out, but let's make it ultra clear now that this is a private variable. Only this script will know about this one. And it's going to be a bool type. So after the private comes the data type. And if it would have been a number, it would have said int there. If it was a string we wanted to keep track of, it would have been saying string there. But we want to just check if something is true or false. So we type bool there. That's the data type. And then we're going to create our field name or our variable name. And let's do jump key was pressed. It's also very good practice to name your variable something very descriptive so you don't have to document it. True. Theoretically, I could have named this variable A or something like that, something that's not used by the scripting language. But then it would be really difficult to know when you're looking at the code, what's A, what's that do? So it doesn't matter if the variable names are a little bit longer, just as long as they're descriptive. They don't take any more space. They don't make your game bigger. They don't make the...
Why is the window now cropped? Oh, it's not that cropped. Shouldn't really matter. Still fine. Yeah, it should be fine.
The game run any slower, it just makes you be able to read them better. So let's keep this jump key was pressed, and down here now we need to move.
Yeah, you should always write your code like, or for someone who doesn't know code, that this person can read it. So jump key was pressed. Anyone can read that. You don't have to know code to read this. But if you name it something as something weird, then and use it down here, then no one knows what this does.
Move this code, so I can actually. We're gonna have to do if statement in both here. So I'll mark this with a mouse. I'll just hold the left mouse button, mark that, press Control-C to copy it, and then I'll paste it down here in the fixed update, Control-V. And we don't really want to do this same check twice, but now we can replace the code here. So in update, we do want to check if the key was pressed down, but we're going to replace this code. So let's take that, mark that one, press delete. And instead of applying the force there, we'll just do jump. And remember, IntelliSense already knows we're going to type this probably, so we'll press tab. Jump key pressed equals true. And now we only use one equal sign because we're going to set this variable or field to true. So now we've stored that variable by capturing it here in the update. But then we need to apply the force down here. So instead of checking for the key down
jump key was pressed.
Let's replace this part of the code.
And now it's actually like a sentence. If jump key was pressed, that's like what you meant and what you should do. Because if jump key was pressed, you can easily read. But if we have if A, what if A? You know what I mean? So you can actually create somewhat of sentences here and easily read them.
Here we're going to type if jump key was pressed equals, remember, true, because if you want to check if it's equal, we don't want to set it to equal. That's why you have to have two here. And also remember that we can take this away. We don't actually need the equals true. The if statement will know that it's going to check if it's true or false since it's a bool type. And now we apply the force down here, which is the correct way.
That's just for booleans. If you have like int a equals 5, something like that, you can't write if a, because the program doesn't know what a should be what. Should a be 5? Should a be 16? What should a be? What should A be?
Way to do it. You check for key presses and input in the update loop, and then you apply forces in the fixed update. Okay, let's try to press play now and see what happens. What do you think will happen? Did you spot anything? So if I press space now...
Exactly the same.
Oh, it became Rocket Man. So why is that? Well, let's look at the script again. It's setting it to true, but it's never setting it to false again. Once it's applied the force here, this variable is kept to true. So every time we hit the fixed update loop here, it'll apply that force because jump key was pressed is still true. So when we've checked for this, we need to reset it back to false. So I'll press enter here and create a new line. Jump key was pressed, we're going to need, so I'll press tab there and let the IntelliSense do the job, equals false. So we set that one to false now. So this should make this only run once now until we press the key again. So let's minimize this one, press play, and press space.
I don't know what keeps loading there, but for me it's loading something all the time. But you guys can see that. Okay, now it's, but you can still triple, quadruple jump.
And now it only jumps once. So that's nice. That's what we wanted. So we've changed and added code now, but the game is still behaving exactly like before. So what's up with that? Well, you've successfully just done your first refactoring of code, and this is something you will be doing a lot when you make games. You won't write perfect code straight away, first of all, and you'll never write perfect code, and you shouldn't really even try to write perfect code, because if you do that, you'll fail to make a game. So what you will be doing is like iterate over your code over and over again,
make it better
over time,
each time,
change it, update it, make it run a little bit better, like make it a little bit more structured, but not more than necessary. And what we did now was really necessary to keep it tidy. We needed to check for the input in the update, and we needed to apply physics in the fixed update. So it was pretty necessary what we needed to do here. Don't spend too much refactoring either. you'd basically get stuck in an infinite loop trying to improve your code over and over again. And
because there's always something to improve.
Saying, someone said that you don't have to write pretty code to make a fun game. And when I Googled that to see who actually wrote that quote, it was only one Google hit, and that was a post that I wrote about 3 years ago or something. So I'm very sure I didn't come up with a quote. But keep that in mind. You don't have to write pretty code to make a fun game. Try to structure it quite nicely and try to make it by the book, but don't overdo it. It's perfectly fine if it's not the best practice. If it runs, if it works, that's great. And improve it over time if you need.
Is this actually true? You don't have to write. What was correct? Was it pretty code? It was pretty code, right? Code to make a fun game. Wait. Okay, I just got this one. I don't know. Someone once said it, I guess.
So now we're finally going to add that horizontal movement, and we have to declare another variable here. So at the top, under the jump key was pressed, we'll do another one. Private float, it's going to be called this time. I'll tell you why in just a second. Horizontal input.
Oh, this.
If you're wondering why I'm starting my variable names here with a lowercase, and then I have uppercase for every subsequent word. It's called camel case, and it's quite a common way to write your variables or field names. Usually methods will have a capital letter all the way through.
Yeah, true, he didn't explain that. So classes and methods and things like that have a capital letter at the beginning, and your variables have a lowercase letter at the beginning. That's just, it doesn't have to be. You could also write it like that, but it's just common practice.
And capital is like fixed update here, for example. And private variable commonly has this. You'll also find that they can start perfectly fine with a capital, and it's really down to personal preference. But this is one type of naming convention that I tend to use. For public properties, for example, I would have started with a capital case. Then I know it's a public one, and for these private ones, I start with a lowercase. So
commonly, you just start with a lowercase for every variable, at least as far as I know. And for classes and functions and stuff like that, you use a uppercase.
Horizontal input now. We've just declared it, but what is?
This would also be fun. You could also write that, but
it's a float. Well, a float
no one does
this. It's a floating point number, it's called. And that's a data type that can store a value like 3.14, for example, for pi. It could also store 3.0, but it doesn't. The strange thing about float numbers is that it doesn't necessarily mean that it's exactly 3.0000 forever. And that's a little bit strange with the floats. It'll do its best to represent a decimal number, but with its limitation. And usually for the purpose of what we're making, it's perfectly fine. It's when you run into, like, if you wanted to check if 3 point and then a whole bunch of decimal numbers.
Double is just a bit more exact. But I guess we don't need it here. Oftentimes also float is used for some specific things, so you can't really use doubles. And sometimes doubles are used more, so just depends on the programming language and what you try to do.
Numbers equals, and then 3 point a whole bunch of decimal numbers. You might run into issues there that you should be aware of. But for our purpose, this is going to be perfectly fine. So a float is a decimal number. And that's because we're not going to check for a key down this time. We're going to check for the input of an axis. And it could be a joystick axis. It could be the mouse movement, for example. But it's also actually registering the axis for the A and D key that we have for movement and for the arrow keys. So here in our update method, let's press enter a couple of times. And let's do, and this time we're not going to do an if statement. We're going to write horizontal.
This is also another one of these commonly used things, or just some, I guess you could call it refactoring, that you put a line in between here. For example, what he does, I guess that's common in C#, I don't know, is that you start with the opening curly bracket, in the next line, but I like this more, and then just put a empty line in between so you can read it more easily.
Horizontal input, tab there, equals, and then we have to revisit this. We still want to check an input like we did before. So we have input, we press tab to complete it, period, and this time we didn't want to check a key, we wanted to check an axis. So get, it's already suggested that get axis. And the reason why it knew that we probably wanted to get axis this time is because we're trying to feed this value back into this horizontal input, which is a float. So it knows, oh, well, you probably want an axis because that will return a float. So that's how it knew that's what we probably wanted.
Big brain time.
And then I have to write here in quotation mark, this is actually a string, and it's called horizontal again. And it says here string axis name. And again, how come I knew that it was going to say horizontal here? And it's because I've made Unity games for quite.
But that's also something I don't really like, actually. These string names. So you could also have like get axis and then, I don't know, input dot horizontal input. Horizontal input is this one. But something like that would be much easier because you can't really mistype this. If you mistype this, the code instantly complains because this isn't a thing. I mean, it's from us, but in this input code, it's not a thing. So if you mistype it, the code instantly complains, and you know that you mistyped it, and you also get this autocorrection. So you can't really mistype it. But if you have, let's put it back, if you have this horizontal, if you like, I don't know, name it horizontal, for example, then the code won't complain, but it also won't work because you mistyped here and the code doesn't know what you want. So that's not really not that good. This code could be improved, but I mean, it works.
Quite some time.
I'm not complaining.
But there is actually a logic to this. So it's not just any word taken out of nowhere. I can go here into edit project settings, and let's go to input manager. And then we have
input manager
here. And then we have horizontal. These are the different axes and buttons. You also
you can actually change the name also.
Instead of doing a key code like we did for space, there's, for example, the jump button here, which is space, funny enough. So we could have checked for a get button instead of a get key down. Here's the input manager,
but I like
and there's an axis
this one more.
And then we can see we've got a negative and a positive button, and it's called A and D. And those are the keys that we wanted to check for, the standard inputs for example, a first-person shooter movement. We were actually reading the alternative buttons because the default negative and positive buttons are the left and right keys. So you'll be able to press either left or right on your keyboard, or A and D to achieve the same input. You also have some settings here, so gravity and dead and sensitivity. And that's keys, when you press a D key, since that's actually a digital key, it'll either be down or up. But these settings here can make it gradually increase it, like you were twisting a joystick gradually or slowly or fast. So these values you can change around a little bit. If it's not direct enough or if it's too fast, you can change these values later on. So that's how I knew that there was an axis named horizontal. And you can revisit that input manager if you want to see what the axes are called again. And you can even define your own ones there as well, if you wanted a yaw, a roll, and a pitch axis, for example, for a flight game. So let's recap a little bit what we've done. We knew that a bool is a true or a false. We knew that a float variable type can contain a decimal number, which is this horizontal input. And we knew that a string here can contain characters. This is a string class. So now we need to use this information. So we've collected here horizontal input. It takes this in all the time, and we don't have to do an if statement, like I said, because if we're not touching these keys, A, D, or left and right, it'll just feed in 0 here all the time. So the horizontal input will be 0 every frame. But as soon as we hit a key, it'll start increasing that value or decreasing it, either negative for left or positive for right. So we need to make something happen now. We scroll down to the fixed update because we wanted to apply the physics. Remember, we have to do that in fixed update. So again here, we'll do get component. It's again the rigid body that we need to access. And now we're going to change the velocity. We don't apply a force. Let's just change the velocity directly. So left or right.
Oops. Not so velocity change.
Press tab to autocomplete that velocity. And now this velocity is specified in a vector 3. And remember, that's something with 3 axes. XYZ or XYZ and a magnitude, so the size of it. So in C#, this might be a little bit confusing, but you actually have to define a new vector3. So we'll type the new keyword here, vector3, and then we have to supply what information here in the brackets, what should the axes be. And here we type in this float variable that we collected up here. So horizontal input.
Yeah.
And that's the X movement here. So left and right of our character. And then comma, we don't want to alter, in this case, we don't want to make any changes to Y, which is up and down. So we'll type 0 there. And then comma again. And we don't want to do anything in the
2D movement
forward or backwards into our scene. So let's
or just horizontal movement.
And this might be a little bit confusing because what we're taking this value now from our left and right key movement, and we wanted that to be the X component of this velocity. And the velocity of a rigid body is the movement speed. Let's press play and see what happens. Okay, so something strange now. What's happening with the gravity?
Okay, wait, what? Let me try it myself. Okay, this guy's floating now.
See, it used to fall down quite fast, and it tumbles over now when I moved it. So it's.
Oh, okay, I can move. Nice game. Let's go. We made a jump. Easy.
Something really strange. We've done something wrong here. And the reason why that is happening is because, remember, here we're adding force.
Oh, you can't actually see it. Wow. Here, there we go. I made the jump again. You can actually, but only if you're on the ground you can move left and right. Or you can't really call that left and right.
But here we're setting the velocity to up and down to 0. We're forcing it back to 0. Okay, so we're applying force, and then directly after we're saying, well, the speed up and down is going to be 0. And that's why it's fighting with itself now. It's applying a force, but it's resetting the speed to 0.
We need a variable for this
one.
We
have to fix that. So instead of setting it to 0 here, we can actually leave the velocity of the Y component, or the up and down movement, to the same value that it was. And we can do that again. It's actually stored in this velocity already. So theoretically, we could copy this, Control-C, and put it for the Y component here. Velocity Y. You can actually access the individual X, Y, and Z components here. So this would say that, okay, we want the velocity to be a vector3, and the vector3 should be the horizontal input, but we want to remain, the velocity of the Y component should be the same, so we don't want to affect that. So let's try to press play again here. So now when we press space, it works. It's not slowing down, it's jumping up and down. And when I move, it's actually not sliding or moving, it's tumbling over, and that's because we've got friction at the bottom of this.
No, jump works. But left and right, it's like shoulder peaking.
Collider, where this capsule collider is hitting the floor tile, we've got friction here, so that's why it's leaning over. But theoretically, we've got something that could nearly be a game now. We've got a challenge here. I have to clear that gap, and I could. So we're on our route to making a game now.
No,
well, maybe not
okay.
a fun one. But
I don't know about this one.
It could be called maybe like Flappy Salmon or something. Could be a thing. I don't know. Flappy Pill.
Flappy Pill.
Flappy Pill. Fill the pill. Fill the pill. Flappy fill pill. Flappy Pill fill. No, I don't know. Also, I noticed this as well. That when we press play now, you can actually jump in the air. So we've theoretically actually accidentally caused a Flappy Bird clone. So by pressing multiple times, we created our first clone of a game as well. So there you go. Just launch it in the App Store now and make millions. All right, so now we're going to start fixing our first bugs. Maybe that's not the most fun-sounding thing, but it could be quite amusing sometimes.
Bug fixing.
Some of the bugs I run into are hilarious. You'll have so many.
I once heard a quote: "First 90% of app or game development, it was app development, is like creating the game, making new features and stuff like that, and the next 90% is bug fixing."
unexpected things happening.
And yeah, it was 1990.
It'll make you laugh over and over again. So take it with a grain of salt. Try to enjoy the bugs and fight your way through them to eliminate them. So in our code here now, there's one thing I was reacting on, and that was that we type the same thing here over and over again. We have get component rigid body here. We've got get component rigid body here, and we've got it here again. And I also happen to know that it's not very good to do this all the time, because every time you get a component, Unity will have to look at the game object, see what components do I have, and it has to grab a reference to that. So,
and you can also save yourself some time in code if you use a variable for this.
2 reasons. A, the code is a little bit messy because we have repeating it, but more importantly, we're actually slowing it down a little bit. It wouldn't really be a problem for our little floppy pill clone, or whatever we're going to call it, but I want to show you how to improve this a little bit. So up here, where we have our fields or variables, let's declare a new one now, private, and it's going to be the type rigid body. Let's call that one for clarity, rigid body component. So we've declared a new variable or field up here, and then now we're actually going to use the start method. Remember that this one only runs once, and the component, the rigid body component, will never change. So here we can type rigid body component, tab to autocomplete it, equals get component,
this one,
rigid body. And now it takes this reference to the rigid body and it stores it in this rigid body component variable that we've got. And now we can copy this here and replace this one down here. So we don't have to type that one over and over again. So we're improving performance and making it a little bit easier on the eye. And again, the game will actually do exactly the same thing now, but we've improved the performance and done it a little bit more by the book. And I just said you don't have to do everything by the book, but you'll find a balance in the end. The actual bug that we had, though, was that the player was tumbling over here. So remember, we press play, it's tumbling over. How do we fix that? Well, there's a few things that we could do. For example, first of all, remember, out of sight, out of mind. So let's collapse the level. We don't want to see that.
1 sec. I already collapsed level.
Here, if we look at the rigid body, there's something called constraints here that I can expand. So when we've got that expanded, we've got something called freeze position and freeze rotation. So we want to freeze the rotation. Remember, it's tumbling over, and we don't really want this player to ever rotate. So we can actually freeze all the rotations. Let's try that and press play. And now it's sliding pretty good. And we can jump maybe still, yeah. We could even clear that gap.
Okay, let's go. Let's go.
Go back. Come back. Come back. Sometimes you'll actually change these things. You could change things on the fly while the game is playing. And remember, it's tumbling over now. And if I press stop now, you'll see that these will reset back. And that's probably a common mistake that you'll do sometimes as well. You'll change something in play mode. I do this, again, all the time, unfortunately. When you realize that you were in play mode, you press stop and everything that you changed reverts back. So that could be a little bit of a pain, but you'll get used to it. Also, the position, we're moving left and right.
I was so excited about a fix for that. I thought he now says, yeah, but if you press like Control N, then you can still save it. But probably there's some kind of shortcut for that.
Right and up and down, but theoretically, our game object could be going this way. And especially if you have a lot of collisions going, then it could actually move in the way that we didn't want. So we can even freeze this. Remember, the blue axis here is the Z axis. So we can freeze the position on the Z axis. And if I press play now, it'll look the same. But we've just protected ourselves from the object being able to fall in or out of the scene.
We could have also just made a 2D game.
So you could actually apply this freeze position as well. Okay, we had another bug as well, remember? Or a feature. And that was that we could jump in the air. And we're not going to make the Flappy Bird clone now. That's already been done. And many clones with it. So we need to protect ourselves from the player being able to cheat and use a glitch jump in the air. There's multiple ways you can fix that, but we'll just pick one method. And again, let's define another variable up here. Private. And it's going to be a bool. And let's call that one is grounded. We need to check if we're grounded or not. And then there's another mono behavior that we can make use. Again, as I said before, there's multiple ways you can do this, and I tend to vary between them, but this is one method that we can use. So we have a method here. So let's start by typing void, and then this one is called onCollisionEnter. And if you press tab, it'll auto-complete it with a bunch of stuff. And this is actually giving us something that we haven't seen before, and this is typing collision. This is the data type, a variable named collision. And that means that when we have a collision...
Okay, give me a second. Private void on collision enter collision. Okay.
We can actually get some free information here. This collision will contain, for example, information of the coordinate where the collision was, what velocity it was. For example, if I type here collision period, we can see here we've got relative velocity to the two bodies that collided. We've got the other rigid body that we collided with.
No, I don't.
The contact points, so where are the coordinates that we hit? We're actually not going to need that information for ours, so theoretically you...
Why don't I get these autocorrections? Is there some kind of extensions? Some kind of Unity extension I don't have? Unity tools. I don't know.
You could actually delete this one if you don't need it. It'll still do what we need to do with it, but we'll just leave it in for now, since that's what IntelliSense automatically gave us when we typed it. So when we detect a collision here, let's just set that isGrounded variable that we created to true. And equally, there's another method called onCollisionExit. So let's do that one. Void onCollisionExit. And then we'll set isGrounded to false. Basically now, when a collision occurs, it'll set isGrounded to true, and when you exit the collision, when it's no longer happening again, so when you jump, for example, there's no collision at that time, so it'll set isGrounded to false. But we need to do something with the information that we are collecting down here. So in this fixed update,
if jump key was pressed and
then we're going to put an exclamation mark here, and they say isGrounded. And
wait, what? Why would you do that? You can just, if jump key was pressed and oh wait, I don't know if where you have to put it, but and is grounded.
Exclamation mark here, or exclamation point, that means if not. So that's actually taken, if it was just like that, it's like if is grounded, then
if this works, or if you have to write it like outside of the bracket and make a new one.
But if there's an exclamation point there, then it's
not.
Is not. You could also type this like this. If it's not true.
Or if it's false.
Is grounded, it's false. So there's multiple ways you can do that. But I commonly keep the code as compressed as I can. So exclamation...
Or you could, but I don't know how to write it, you could write a extension. I don't know if there's extensions in C#, but in Swift there are extensions. So that it's not is grounded, but you could actually write is not grounded, so it's a bit more readable than this one.
Is grounded means if not is grounded. Then we want to execute something here. And here I'm just going to type return. So remember now, the physics engine and mono behavior will run this fixed update every time it hits the loop. But then it'll detect now, okay, if it's not grounded, then I'm going to return. So I'm going to not execute this code that's down here. So return, you can actually exit a method earlier by doing
you can do that as well.
Okay,
but this is just a bit, I guess, more readable and also just shorter. So I like this one more.
Is grounded. It's going to continue here, and it's going to do our key press here for the jump. It's going to do our movement velocity. So if we press play now, and now I'm trying to jump in the air and it's not working, and that's how we wanted it. We don't want to do air jumps.
Okay, but now I want to know if this works like that. Yeah, okay. Okay. If I press space in the air, then he instantly jumps again.
And now I'm trying to jump in the air and it's not working, and that's how we wanted it. We don't want to do air jumps.
Okay, let's see. Yeah, let's just write it how he did it. Because I don't know why this is happening. It's not ground every turn.
In this one, you could do, if you want to have double jump feature, you could check a counter instead, for example, to see if it's been pressed once or twice. But let's just keep it simple for now. So you can only jump when you're on the ground. And now I've ran into another bug here. See that I'm actually trying to move this object, but nothing is happening. So what could that be? And I think what's happened here is that we're actually hitting between these two blocks. So if we try again, let's see if we can replicate that problem.
Oh, true.
I'll move, I'll jump.
Can't move, so
I'll go here. And there it stops. And I think we're hitting right between two colliders now. So it's exiting and it doesn't really know what to do now. It's right in between these two colliders. So maybe that's not the best method to check for this collision. Okay, so how do we fix that problem? Again, as I mentioned before, it's quite common when you make a game that you'll find that you'll try one approach and it might not work, or you'll find a bug, and then you have to find a different method to do it. So maybe this on collision enter and exit wasn't the best approach, but hey, we learned that those existed, so it wasn't exactly for nothing. It was pretty good to know that anyway. But let's scrap this method and let's find something else. Let's even take away this that is grounded and go back to where we were. And let's think of a new way. To do that, we can actually check. There's another physics feature called
okay, got everything.
Overlap sphere, and that will check if a sphere is overlapping with something, like a fictional sphere. And if we imagine that we want to check at the feet of the player if it's touching ground, maybe that's a better approach to do it. So first what we're going to do is we're going to put another reference up here, but this one, we're not going to make it private. We're going to do public, and this is going to be a transform. So why is that? Okay, so ground check transform, we're going to call it. And you'll find something is different now. When we do public here and we minimize this, then when I click on the player here, we can see that something happened. It's exposed in the inspector. Okay. So ground check transform, it actually inserts some spaces here for human readability. You can also change the width of this if you want. So it's exposed it's called here. And this is the easiest way to expose something. You could also do something which is I think the proper way to do it. So private you could do, but there's a little tag you can put here as well. Serialize field.
Okay, I've never seen that. Serialized field. Okay.
And that will actually also expose it here. And this is actually the proper way to do it. So we'll leave it like this for now. If you get a warning, I should also mention, then you can actually set that the default value should be null. So again, you could either just keep it at public to keep it simple, or you could do this method, which is the proper way to expose stuff in the inspector. The result is going to be the same. It's just that you're not exposing it to classes as well. It's just in the inspector that you do it. Okay, so this now, we've got a ground check transform, but what should we do with this one? It says none here, no transform. And remember what a transform was. That's the position, rotation, and scale of something, of a game object.
Field playground is assigned, but its value is never... okay.
So I right-click on the player here, and let's create an empty game object now. And since I right-clicked on the player, it'll create that as a child here, and it's called game object. But let's press F2 on it and rename it to ground check transform. And it's positioned in the same place now, in the relative position of 0, 0, 0 of the player object, the parent object. And we want to move that to the feet because we want this one to be positioned. We're going to use this as a little helper object to know where our feet location is. And to position it properly, remember we could hold the Alt key and left mouse button to pan around here. But we want to position it pretty much exactly at the bottom. So you can see these this little axis tool up here. First of all, you can click on an axis like this and it'll view it from the side, but we still...
I was still in play mode. Now I know what he was talking about. Ground check transform. Okay.
Still don't really know exactly where it is because it's perspective enabled here. So even if we pan around, where is the bottom exactly? You can then also, if I rotate, see that it says perspective here. If I click on that one, it'll switch to isometric or orthographic view. And that removes perspective. So if we click on this Z-axis again, you can see now it's basically looking like a 2D game without the perspective. And now it's really easy for us to reposition this. So we can check this, make sure we've got this ground check transform, and then we slide it down on this.
Wait, why is this? I wanted like. Wait, what? Bro, I don't. How has he done this? Give me a second.
You can then also,
if
I rotate, see that it says perspective here. If I click on that one, it'll switch to isometric or orthographic view. And that removes perspective. So if we click on this Z-axis again.
Okay. It's like, okay, now I have this one. And I press on, yeah, okay. Now it's better. What was it? To move like up, just moving up like this. Okay.
You can see now it's basically looking like a 2D game without the perspective. And now it's really easy for us to reposition this. So we can check this, make sure we've got this ground check transform, and then we slide it down on this axis and position it at the feet. And now it happened to be that this is 2 units high and the center is here. So the proper position here is probably -1 to get it exactly on the feet. And don't forget to switch it back as well to perspective if it looks all weird on you. And then you can just hold the Alt key again and rotate. And now this child object now is right at the feet of this capsule. So on the player, we're actually, it still says none here. And that's now it's because we need to assign this one. We need to connect this reference. So I take this game object from the hierarchy and I drag it all the way down here to this exposed field. And then it's got this link now. If I click on this one, it'll highlight it here. So I know that this is now connected.
Okay. Like that? Yeah, like that. Okay.
This is also something you'll be doing a lot when you create your game objects. You'll expose things here. Maybe you want a camera follow script and you want to drag the camera reference to it. You could expose, for example, the jump height or the speed that a character can move. You can expose all sorts of things here in the inspector. And instead of having to go back into the code to modify it, you can do it out here. But now we've created this little reference. So let's get back to what we were doing. And so we've got this transform exposed now. So we can use this now. And down here in the fixed update, let's do a check here. If
transform, yeah. Okay. But did he delete the is grounded? Yeah. Okay, he did.
So we can use this now. And down here in the fixed update, let's do a check here. If, and then we can access the physics engine directly here, physics. And then we've got this overlap sphere function. And again, I know this because I've created a lot of small, simple prototype games, and I've found that there's so many ways you can do things. You can shoot raycasts to check the distance to the ground.
I'm checking this. Unity auto completion VS Code. Doesn't matter. Maybe if
you can do
maybe
in this case
check again later.
Check collisions. There's so many things,
and change it.
And this is just one more
because I just don't get these Unity auto completions.
The method that you've got at your disposal. So this is expecting something, and we can see here in the little hint here that.
And it also is not underlining this because because I don't know actually.
Expecting a position.
Just things
and
that
remember
works.
now that the transform that we exposed up there, the ground position, then that was a transform, so we know that that has a position. So I can check here, ground, check transform, and then this one has, remember, it's got position, rotation, and scale, but we only need the position here. So position, and that's going to be the world position, comma,
position.
And then we have a radius here. So how big should this check be? And we remember that the character's height was 2 units, the capsule. So maybe we only need to check a little small area down there. So maybe we'll keep it at 0.1. Here's another little strange thing. When you type a decimal number in C#, you actually need to add F. So those squiggly marks there that was there before, it's because it needed to have F to indicate that it's a float number that we want. And then it's still complaining for some reason. Let's complete the code. So why is this not working? We have a ground check transform position, so everything looks right. But if we hover over these red squiggly marks, we can see, okay, it says cannot implicitly convert type collider brackets to bool. We're trying to check if this is true, and it's not actually returning if it's true or not for us. It's returning something called an array of the colliders that it's collided with. So let's say that this overlap sphere was really big, checking for an entire world. Maybe it like encompasses 4 tiles. Then it's actually returning references to all those tiles. And we're only interested to see if it's colliding with anything at all or overlapping anything at all. So we can access the length now of that array. And the length, it will say how many components are we hitting at the moment. And remember, we only want to run this code now if we're connected to the ground or if we're touching the ground. So it means that it has to be at least one collider that it's overlapping with. So let's check if this length, the number of colliders, is 0. And if it is 0, it's not colliding with anything. Then we know that we're probably going to be in the air. So now we'll do the return here.
Right.
So we'll check, is this little fictional sphere of ours, that's only 0.1 units in radius, if that one is not overlapping with anything, we're going to assume that we're in the air and we're going to exit this fixed update. So let's try to press play again. And that's still not working.
We can still double and triple jump. Okay.
So why could that be? Well, it's because the capsule collider, it's got a collider itself, so it's actually colliding with itself.
Oh, wow.
There's multiple ways to fix that. You could use something called layers here, for example. You could create a new layer and call that one player, and we could have this little overlap sphere ignore that layer. That's one way to do it. So since it's always colliding with its own collider, we could go for the method of saying that, okay, if the collision is only 1 for this little sphere, then return. And what this is saying now is that I know to expect that I'm always going to be colliding with myself. So I'm going to expect if I'm in the air, it's only going to be colliding with me. If I'm near the ground, it's going to be 2 collisions because I'm going to overlap my capsule collider and the ground collider. So let's press play now and have a look.
Bit skeptical about this one.